So looking at number 2 on L'Hopital's, and let's do the algebra way. Do you remember what to do? The algebra way? Well, hold on. First things first. We plug in 3. We get root 4 minus 2 over 3 minus 3. Help, that doesn't work. Okay, so that doesn't work. So let's try the algebra way from way, way, way long ago. Do you remember what the algebra way is?
No.
Conjugate. Yes, rationalize. Square root of x plus 1 plus 2. Square root of x plus 1 plus 2. So it looks terrible, but when you FOIL it out, things work out. So first, root x plus 1 times root x plus 1 is x plus 1. What about the O and the I? The O and the I when I FOIL the top? They cancel. That's why we multiply by conjugates, so I don't need to write that one out. And then the last, negative 2 times 2 is negative 4. So the top becomes x minus 3, which is super convenient because the bottom has an x minus 3 that we could cancel. So we don't FOIL the bottom because we want the x minus 3's to go away. So if we plug in 3 now, well, safe stop, 1/4, but we could stop right there. But yes, it is 1/4. So that's the algebra way to do number 2. Do I need to do do L'Hopital's rule?
Sure.
On that one as well, and we'll see if we get the same thing. So we already said, maybe we should back up here instead of putting question marks, we should be a little more specific. That's indeterminate, therefore we'll use L'Hopital's rule. So the first way was the algebra way. Now we'll use L'Hopital. Limit as x approaches 3. So that's x plus 1 to the 1/2. So if I take its derivative, 1/2 x plus 1 to the negative 1/2, chain rule times 1, and then the derivative minus 2 goes away. And the derivative of x minus 3 would just be 1. So clean this up a little bit. 1 over 2 square root x plus 1. Plug in 3. And we get 1/4. What do you know? Algebra method, L'Hopital's rule method. Same. Looking at number 14. Limit as x approaches 0 from the right of negative x natural log x. Well, first attempt is to substitute. We're pretty sure that's not going to work, but let's plug them in anyway and see what happens. So negative 0 times natural log of 0 plus a little bit. It'd be helpful if we knew what the natural log graph looked like. So the natural log of a little bit more than 0 is negative infinity. So this isn't officially one of the indeterminate forms, but it's kind of indeterminate, right? Because this is a little bit more than 0, but headed to 0. This is infinity. So it's like, well, which one's which one's stronger? Is that a stronger 0 or a stronger infinity? Like which way are we getting pulled here? We don't know. This is indeterminate. So we're going to do a trick that I didn't show you yesterday. Let's just leave the negative in the top. But I could rewrite x as 1 over x. And initially you'd be like, well, why would you do that? Except that when we write it like that, now it's going to put it into one of those indeterminate forms. So this is one of those math tricks. It's like, well, why would you ever make this more complicated? Except that now we have infinity over infinity, not equal to. That's indeterminate. Therefore, let's try L'Hopital's rule. So derivative of natural log is 1 over x. Derivative of 1 over x, I'm going to come out here to the side, make sure I don't mess this up. That would be negative 1 x to the negative 2, which would be negative 1 over x squared. Now I've got, I don't know, a keep it, change it, flip it problem, I guess. Negatives will cancel. So the limit as x approaches 0 of x, that would be 0. But the trick on 14 and 15 is to rewrite x as 1 over x in the bottom, because that forces you into one of the indeterminate forms, which then allows you to use L'Hopital's.